Imagine a soccer team where everyone is the goalkeeper versus a team with a diverse set of skills from defense to attack. While both teams have their strengths, only one has true variability, and that's what we're exploring today. Hi, I'm Matthew Courtney, and here we talk all about education research and data. So if you're into that, be sure to subscribe to this channel and come be a part of our community. Variability. It's a concept that runs deep in every data set, painting a clearer and fuller picture of what's really going on. Variability tells us how spread out or how mushed together the numbers are in a data set. Think of it like the difference between a flat terrain and a mountainous one. The peaks and valleys, the highs and lows, they all give depth and dimension to our data. Let's consider the primary measures of variability. First up is the range. It's the simplest measure, the difference between the highest and lowest values. So in a set of 5, 7, 15, and 20, the range is 20 minus 5, or 15. Variance. This one gets a bit technical. Variance measures the average square differences from the mean. In other words, it considers how far apart each number in the dataset is from the average. Next is standard deviation. Think of this as the average difference from the mean. Technically, it's the square root of the variance, but it's super handy because it's expressed in the same units as the data you're working with. Finally, there's the interquartile range, or IQR. This is the range between the first quartile, or 25th percentile mark, and the third quartile, or 75th percentile mark in a dataset. IQR helps us to understand the middle spread, excluding those extreme values. It's particularly useful when you have outliers that might skew your perspective. Okay, I know that sounds like a lot, but we're not done yet. I'm sure you're wondering why you should even care about variability. Well, because in many ways, it's more truthful than the more common measures of central tendency. An average can hide details, but variability reveals them. Let's consider a classroom-based example. We're assessing three classes based on their test scores. Classes A, B, and C all have an average score of 75%, but how they got there is entirely different. Class A scores cluster between 73 and 77%. They have low variability. Everyone's pretty much on the same page. Class B, their scores spread from 50 to 100. That's a much higher variability. In Class A, teaching strategies might focus on refining what's already working. But in Class B, there's still some more work to do. Some students might need challenging extensions, while others need to go back for more foundational support. Then there's Class C, with scores ranging from 65% to 85%, but with most students scoring between 70% and 80%. The interquartile range here highlights a consistent middle group with fewer extremes. This is a class that might benefit from pull-out interventions on the low end. Understanding variability is like reading between the lines. It unveils the nuances. In research, it helps us determine the reliability of results. In teaching, it gives us insights into student dynamics. In everyday life, it reminds us that diversity and deviation are the norm, not the exception. Let's turn now to a spreadsheet so I can show you how to calculate these scores in real time. Here's a distribution of 25 random scores. Let's calculate the range. First, we must find the maximum value. We'll select an empty cell and then type $max, open parentheses. We'll select our data, type a close parentheses, and hit enter. Next, we'll find the minimum following the same procedure. In an open cell, we type min, open parentheses. We select our data, type a close parentheses, and hit enter. To calculate the range, we input a formula by selecting another empty cell and typing selecting the cell with our maximum score, typing a minus sign, selecting the cell with our minimum score, and hitting enter. The range is 98, pretty high variability. Now let's calculate the variance. We're going to select an empty cell and type VAR, open parentheses. Then select our data, close parentheses, and enter. The variance is 1085.31. We'll keep going right along with standard deviation. Hopefully you're starting to sense a pattern here. We're going to select an empty cell and type STDEV, open parentheses. Then select data, close the parentheses, and enter. The standard deviation is 32.9. Finally, let's do the interquartile range. This one works similarly to the range. We will first calculate the two quartiles by selecting an empty cell, selecting equal sign, quartile, open parentheses. Then we'll select the data, type a comma, and type 1 for the first quartile. Close parentheses and enter. The first quartile is 12. We'll do the same thing for the third quartile by typing equal sign, quartile, open parentheses. We select the data, type a comma, type 3, close parentheses. Hit enter. The third quartile is 74. To finish, we subtract the third quartile from the first by selecting an empty cell, typing equal sign, third quartile minus first quartile, enter. The interquartile range is 62. If all this spreadsheet work feels like a bit much, don't worry, I understand. Check out my free distribution analysis tool at www.matthewbcourtney.com/DAT. This will allow you to upload your data and calculate all of these statistics and more in just a matter of seconds. Understanding and calculating measures of variability like range, variance, standard deviation, and interquartile range empowers us to see beyond mere averages and dive deeper into the real essence of our data. Whether in education, research, or in daily life, recognizing the importance of variability enriches our perspectives, enabling us to make more informed decisions and understanding. Remember, it's the differences that add depth to our analysis and color our interpretations. Keep exploring, keep questioning, and always strive to uncover the full story behind the numbers. If you found value in this video today, make sure you like and subscribe, and check out some of the other videos in this playlist. I'll see you next time.